Let's look at how to define polar coordinates and how to graph them. In our regular rectangular coordinate system, we have two perpendicular axes, our x-axis and our y-axis. But for polar coordinates, it's a little bit different. We start with a ray that moves towards the left. The initial point on this ray is known as the pole, and this is known as the polar axis. The idea is we're going to go some distance down this polar axis, and then we're going to go around some angle. So a point would be like something right here. This distance here is denoted by r, and this angle is denoted by theta. So this point P is denoted by r comma theta. We denote it by how far out we go and the angle of rotation that we need to look at. Here's what a polar graph looks like. We have our polar axis, and then we denote several different angles. If we want to denote a point like 3 comma pi over 4, we would go out 1, 2, 3 to this third circle, and then around to pi over 4. So this point here would be point P. If we wanted to look at something like 2 comma 135 degrees, this time we would go out to the second circle and around to 135 degrees. I'm going to denote this one by A. That would be this point here. We can also do negative values for our R value. We'll denote this one by B. This tells me we're going to rotate to 3 pi over 2, which is down here along the bottom. And so this point right here would be 3 comma 3 pi over 2, and that's not what we want. In order to do negative, essentially we rotate it around 3 pi over 2, and we're going to move 3 in the opposite direction. So it's actually this point here, B. Whenever we're dealing with negative, we can think about it as rotating around and then moving back in the opposite direction to count out how far we're going. Another example, if I wanted to do -1 negative pi over 4, negative pi over 4 rotates me to this point here, pi over 4 in the negative direction. And then we want to go out -1, so we're actually going to go in the opposite direction, so that would be this point here, C.